come to know. So what I wanted to talk about today was the whole Android upgrade thing that is sort of a it's a miserable experience for all involved, including consumers that they just want the new stuff as quickly as possible, and there's a lot of challenges to get there. And since we started the company and tried to take this from open source to commercial products, the effort level has increased tremendously. It's taken us longer to get stuff out there. And I just kind of want to talk about like what goes into an Android upgrade and how we do it and what we're doing to go faster when N drops in a couple of months. So yeah, we actually just released our latest version, like literally yesterday, I think. And our commercial version is in final testing. So that'll be hitting devices very soon. But the thing I hear the most is, "You suck. Why did it take so long?" Like constantly, and there's a good reason why it takes so long. Pretty much this, right? There's a lot of pieces to the puzzle of actually doing an Android upgrade, right? You have the code from Google. You have the Linux kernel, which is completely different it's customized for every device. And on the left here is, you'll see this in the CyanogenMod project, right? We have to deal with the code from the chipset manufacturer, everything from our open source project, as well as like device-specific changes. For the commercial product, that's where things get really interesting. We have to do GMS and the GMS certification. We have to deal with the baseband, the modem, the DSP, all that firmware, all those blobs, all that stuff. We have to bring a lot of vendor code for supporting cameras and other features. And then our partners will always have all kind of crazy requests, and we do our best to do all the customization and stuff that they want. We have our own proprietary stuff on the commercial version, but then we get into actually running the wonderful test suite known as CTS, which takes an entire day to run. I'll talk about it a little bit more, but it's brutal. And then once that's done, we work with the factory and go through all the testing that needs to be done to make sure that they can actually build these things with the current release of the software, and then all their QA as well as ours, and then we finally get to ship. And during the entire process, I don't get to sleep, which is its own kind of delightful experience. Okay, so when you start off with an Android upgrade or bring up, you're always starting with the latest code from Google, AOSP. Now their release schedule has kind of gotten longer and longer. I think it's up to about a year now since for the last 2 or 3 releases. Where the first couple, it was like, I think the first 3 releases of Android came in the course of like a year, and then it gradually slowed down after that. But the longer we have to play, the more stuff that we build and shove in there. So the harder it is next time to do an upgrade, because we have this code we have to bring forward. And it's a lot of code, right? So Android itself is about 470 gig repositories. CM is somewhere around 1,000. Because we have all these device configurations and a lot of our own stuff that we've brought in over the years. So with every new release, there's thousands of new patches, lots of new features, major refactoring, and changes in critical subsystems that kind of throw you completely off and force you to rethink your entire approach. And the tough part about Android is all the development's private until the code drops, right? So, once a year, there's, this big, over-the-wall code push to AOSP, and then a couple of MR releases along the way, but, nobody really has any idea of what's coming until it comes. Now, some tier 1s do get early access, so, they tend to be out in front of everyone, but, you gotta be a Samsung or an HTC or a, major manufacturer. We're just a little guy, so, we don't get to play there yet. But you know, one of the hardest things is the test requirements, right? And with every release, you know, the test suite gets bigger, more complicated, and you know, there's you know, just unexpected stuff that you didn't think of before that are now being tested, or the security model has, you know, gotten stronger, and you have to test all kinds of new stuff, and your Android for Work comes out, and you basically have to retest everything, and everything changes. So, I mean, there's a few big challenges, right? Whenever you're trying to do one of these, you know, like every OEM kind of has to go through this, and you know, I mean, it's no different for, you know, CyanogenMod and Cyanogen Inc., right? I think the biggest issue is the feature overlap. You know, we do, you know, we have a lot of opportunity. You know, I mean, it's just the nature of open source. That, you know, you get the code, you make a whole bunch of changes. I mean, anybody that's into ROMs does this. You know, every OEM does it. You know, we add a whole bunch of new features, and you know, hopefully build something better than AOSP, right? That's kind of the point. But in a lot of cases, people will adopt those features, and you know, you have to decide to you know, to fight or flee, kind of thing. You know, if you played with the end preview, it's like all of our features again. But you know, it is what it is. It forces us to be innovative and come up with new stuff constantly. You know, and then there's all the API changes, the HAL changes. You know, Google's gotten a lot better about that, but you know, it's still a challenge. The refactoring that happens is what's really interesting. You know, sometimes, you know, what we'll see is you know, they'll do something like rewrite all the guts of the phone app, right? And you know, that's great. They improve the code, but you know, we have to rewrite all of our stuff now. So it's, you know, it takes a lot of you kind of have to dig through all the code and completely understand exactly what they're doing, and you know, across all these different code bases, it's you know, it's a massive undertaking. Then you'll have things like, you know, the UX upgrades, right? Like, you know, oh, here's material design, here's Holo, and all of your stuff, you know, you want to comply with all those, you know, all those guidelines and everything. So you might have some work there to do as well if you have your own apps. You know, then there's always the inevitable kernel and toolchain updates where, you know, suddenly GCC 4.9, you know, like your kernel doesn't compile properly. Well, like it actually compiles, but it crashes in unusual ways because there's some kind of like, you know, weird alignment issue or something that, you know, will keep you up for days on end trying to hunt down. And, you know, always the device-specific stuff. And, you know, more recently, the Android security model is actually like turning into, you know, something real and like, you know, something that's really powerful. So you have to keep that in mind. You know, everything you have to do with SE Linux, and you make sure everything has a policy, and you know, and it's all locked down. It's all tested as well. So like you can't even skirt around it if you wanted to. Yeah, and you know, just new features, which is kind of like, you know, we bring in all of our features on top of AOSP, which you know, we'll talk about here in a second. So. You know, you put on all this new code, and depending on the size of the release, like for a major Android release, you know, if anybody's ever tried to like git pull like a major Android release into a current one, you basically end up with this on the right. You know, it's just endless merge conflicts, like until like, you know, you can't even like see straight anymore. So. You know, you have to decide if you're going to rebase or merge, and you know, so for the major releases, we do rebase, right? We basically do, you know, git rebase, and you know, pull in everything that we can, fix the conflicts on the way, and leave out the things that we've decided that, you know, we're gonna punt until until we figure out whether or not we're going to refactor them, if we're going to keep those features or what. But it's just a massive effort. You know, it takes a lot of people to pull it off. You know, on the open source side, you know, we have like a lot of help from the community, and then we do, you know, a lot of stuff at the company. Unfortunately, everybody gets gated by like the merge of the core piece, the frameworks, which is brutal, and you can't really distribute that work among a lot of people. So it tends to be like myself or like Ricardo, who like just kind of goes at it for like a couple of days until it's done. And you know, it sucks. I've done it like 7 times now, and you know, every time it's more challenging. You know, and then there's all these sub-projects, so you have to deal with all the apps, right? If you have changes in those, if there's upstream changes, you have to deal with those, and you know, you still get this mess on the right here. And you will inevitably mismerge something, and everybody will hate you. And you'll introduce some subtle bug that because of a one-line thing that you didn't expect, and things will break in some way that you just you couldn't foresee. And hopefully you catch it in testing, but since for our open source stuff, we do all the development in the open, and when people start using nightlies and run into that stuff, they just kind of start to hate you. And whenever the code's moving really fast. But I mean, that's why we do it, right? So we can get more testing. And I just try not to rage quit in the process. So let me talk about the testing. After you get through it all, you get all the code merged, you're ready to go. It's kind of nuts. So as you can imagine, testing all these apps, testing all the framework features, it's a huge effort. And it's different for every device too. Like, you might have one device that works great, and then another device, you have some issue because, the screen size is different, or, the sensors are different, or, there's just something subtle about it, right? So for every device that you do, you have to retest the whole thing, like, end to end. And it's even more complicated because, like, you have to, you're, with an Android upgrade, you have to retest all of your code on this, on this new baseline, right? So you're kind of underwater from the beginning. But fortunately, we have CTS, which is this massive automated test suite from Google. And there's also XTS, which is if you're doing like the GMS certification. It's more specific for Google services. Where CTS is, it doesn't really involve any of the Google services. It's just the platform stuff, right? But they test everything. They test like everything from your audio, video, what's your frame rate? Is there jank whenever you're rendering OpenGL? Like what's the frame rate there? End-to-end testing of like the security model. Are there any road-readable files? It's just kind of this endless thing, right? And it takes all day to run. And it's even more fun if you're building a 64-bit device because the whole thing has to run twice now. So so it's really long, and fortunately you can shard it between multiple machines. So we do that, but it's still, even if you run it across like 10 machines, it still takes like all day. There's a bunch of videos that are part of CTS, and if you've ever run it often, as soon as you hear one of these things, like you'll want to claw your eyes out because like they just play on loop like over and over again. And never run CTS in your house, because there are certain tests that will turn up the volume on the phone that's attached and play like a sine sweep or an alarm tone at full blast and wake everybody up, including your 3-year-old daughter, and nobody is enthused about that. There's also tons of bugs in CTS, right? So in a lot of cases, we get waivers whenever it comes time to do the validation and everything. But sometimes they're just bugs, right? Like Google does the testing on the Nexus devices, but for different form factors, they'll run into some funny stuff. One of the notorious ones I remember was we were trying to we had one test that was continuously failing, and Chrome was it was always giving black screenshots in the recent apps, right? And what it turned out to be was, since the device had hardware keys, Google hadn't bothered to actually run CTS on a device that had hardware keys, and it changed the layout ever so slightly, and they made an assumption that the navigation bar was there, right? So when they tried to draw the screenshot, it didn't fit the screen, and Server Slinger just said, "Okay, screw you. I'm just going to show black." There's a lot of stuff like that. More stuff around sensors, we just had to deal with, and how fast they record and everything. If there's any timings that are off, it kind of gets messed up. And there's a lot of bugs that carry over from many releases that we fixed. Fortunately, CTS is they have a lot of external contributions on the Android, the AOSP Garrett. So if something is really odd, you can usually go on there and find that there's like 5 different OEMs that have submitted the same patch and they've been sitting there for like 6 months or something. But in those cases, you usually have a good case for being able to skip it. But on top of CTS, we also have to do a whole bunch of other testing that we built up a fairly impressive collection of lab equipment in order to do it. A lot of it is you start with power testing, right? Like what's the power consumption of the device when it's just sitting there, right? What's power consumption whenever Wi-Fi is on, or whenever the LTE modem is on? What's the power consumption when you're playing music, right? Is it offloading to the DSP, or is it playing in an Android using tons of power? What's it like whenever you're just idle screen and sitting at the home screen? So we've had to come up with like characterization about exactly what those numbers should look like, and then the performance numbers. We're kind of nutso about performance, and if you ever use like a 1+1 or most of the commercial devices we've done, we've kind of gone overboard with trying to make them really fast and snappy. So we try to push it there, and then there's like the NTDF, right? Mean time between failures. In this case, you have to run the wonderful monkey tool, and you have to run it for days and days and days, and see what breaks, right? And in most cases, it's everything. You'll get like like NPEs in the launcher, and just other weird stuff that like you would never really experience like using the phone as a human, but it'll like do weird drags and just tons of horrible things to the device and manage to break everything. But you just log it and you fix it. In most cases, they're easy, but some of the requirements around MTBF, especially like if you're if you're working with a major OEM or like a carrier, the requirements they have for MTBF are really crazy. Like you basically have to be able to run Monkey without any crashes for like 800 hours or something like that. So and then actually retesting that takes 800 hours of Monkey running, right? So it's a time-consuming process. And then you have to, and then you have audio, video, camera stuff, right? And for all that, you need specialized equipment. We have audio precision analyzers. We have, we have light boxes. All kind of, various charts and lighting equipment, and yeah. So I'm a AV person, so I love to work on that stuff. It's definitely challenging, and you have to know how to use the equipment too. So it's not just like you buy this thing and it gives you all the magical answers. So despite all this, we added a bunch of shit to CM13 anyway. Yeah, so we the main point of CM13 though was like eliminating a lot of this technical debt so that we can go faster. It's unfortunately taken us several months longer than we had hoped. But it's a pretty solid release. We did a whole bunch of AV improvements. One of the things that we have in CM that's different than everyone else is we can play essentially any media format on the planet because we supplement stage fright with FFmpeg and a custom OMX plugin that if stage fright can't play it, we hand it over to FFmpeg, and it can play it pretty well. Even though it's software rendering, it's like hyper-optimized for ARM and everything, so it's still pretty low power. An interesting thing about that, in the M release, I mentioned we have to deal with all this upstream code, one being the BSP code from like Qualcomm and those guys. Qualcomm makes a lot of changes around AV also because they have their own, they have a DSP, they have a dedicated core for radio playback and everything. So, they add a lot of stuff to make sure that, everything's taking advantage of it. Well, for some reason or another, in the past, the bulk of that work has been open source. Well, they decided to start pushing it more into their proprietary side. And in order to do it, they used this static library that kind of gets linked across all of the media libs on Android. And it's compiled against the headers and stage fright. And then their proprietary library, which nobody gets the source to, including partners, is also compiled against the same headers in stage fright. So if you change anything, you break the whole thing. So it doesn't work. So we fought with this thing for a while. We talked to Qualcomm, and they were just kind of like, well, if you want to use it, that's great. If you don't, you're on your own. So we decided to go on our own. We ripped all that stuff out, and we went all in with our own, AV parser and everything. The FFmpeg-based parsing and everything to replace the Qualcomm stuff. And it's great. It works across all the devices, and it can play anything. So I'm pretty happy with that. We did a big update to System UI and the quick settings tiles, which looks frighteningly like what you see in M. In fact, it's exactly what you see in N. If you've used the developer preview, the sliding panel and everything, which is fun, wonderful. Imitation is the highest form of flattery. One of the other cool things that we have that it's partially getting released, and we'll put the APIs out there in the MR releases, is a live lock screen, right? So basically, as part of a theme now, you can have a custom lock screen, right? We basically give you a service to render on. You can do OpenGL, whatever. So you can flip that open and put a game there if you want, or just some colorful stuff. Pretty much anything you want, you can put there now. So we're gonna have more info about that coming up. The guts are in the 13 release, but there's still a little bit more polish that we're gonna put on it before we're gonna release all the APIs for that. The open source guys did a new camera. It's based on the Qualcomm Snapdragon camera app, and they fixed up the UI and made it work across all the devices. So yeah, it's a nice little improvement if you use CM. There's a new messaging app. We reworked Privacy Guard for the M permissions now. It was a straightforward thing, but it was just one of those things where you had to rewrite a lot of the guts of a feature, to kind of sync up with upstream. Protected apps are actually protected now, right? They weren't actually protected before. They looked like they were protected, but it was really just the launcher hiding things. You can still launch things if you fired an intent. But we integrated all that into Activity Manager now. So if you say that you're going to protect these apps, they're actually protected now. I added display modes, which lets you have different calibrations for the screen. You'll see this on the commercial devices, and some of the open source guys are starting to use it for some of the built-in Samsung stuff. To set these up though, you kind of need special equipment. I mean, we have like a $20,000 spectral radiometer that we use to do the calibration, so it's a little tricky. Another thing was we do audio effects works on any stream now, so you can have all your audio enhancements and everything. They work on everything now, and not just like the apps that send that little intent that turns it on. That was like one of the big complaints, because we talk about that feature a lot, and then people are like, oh, it doesn't work with like Spotify, or it doesn't work with Tidal. It's like, well, yeah, they're not actually using the right APIs to turn it on. So we said screw it, and we kind of made a better way for it to activate, where we can essentially attach to anything. But yeah, we wanted to get rid of some of the technical debt, so what we did was we made this thing called CM SDK. CM SDK has a couple of pieces. The big goal is to reduce our footprint on Android, right? Because carrying all this code forward, especially in the framework, is hell. It's also difficult to test, everything across the whole framework. So, we started shoving everything into this new SDK, right? And the SDK has a couple of different pieces, which I'll talk about in a second. On the client side of it, you can link with the SDK with the static library that it spits out to take advantage of anything we've added. It's mostly geared towards the platform right now. We're adding a lot of stuff to it. If you do want to use it in an app, you can, and it'll degrade gracefully. So if you're not running it on CM, it's not going to crash. So if you want to use something like the tiles interface, or any of the hardware, the hardware APIs or anything we've added in there, you can, and it'll work just fine in your app, and and your app will still work on TouchWiz or whatever. But what this thing really is, it's a framework for instantiating services inside of System Server. So there's a whole bunch of stuff that gets spun up by the system. Activity manager, package manager, display power controller, auto brightness controller, all these different services and publish binder interfaces that you can talk to. This turns out to be a ton of stuff, right? So we needed a way to essentially load these from somewhere else, right? That wasn't all like intertwined with the platform code. You can configure only what you need, right? Like if you were using this in one of your own projects or you're building a ROM or something, like you don't have to use all of our services. You can just turn on what you want. Like if you just want to use themes, you can do that. It also bridges a gap to some of the proprietary stuff we're doing on the commercial side. Because we don't want to kind of mix the two worlds very much. Like our proprietary stuff is actually built on top of CyanogenMod as these like overlays and extra configuration that kind of brings in more stuff. So this helps us out there. So like if you have a look at CM SDK, if you've checked out the code, we have the actual API specs there. The system services are all there. They're just classes that extend system service. They publish binder interfaces. It's really, really straightforward and easy to set up. We've moved all the shared resources that we previously stuck in the framework res.apk. We moved all of those to the CM SDK, so we have our own resource package now. We have migration tools that whenever you're coming from 12, the next part, packages, we actually have our own settings provider as well. In Android, Android provider settings, and there's tons of stuff in there. In CM, typically, we have like 500 or 600 things in there, and it's a mess. So we made our own settings provider to get all that out of the framework. But there's migration tools that bring it all forward and actually like test the migration like on the host and everything, which is pretty nice. There's demo code in there if you want to check that out for like using all the stuff. There's the SDK library itself, which is built as like a static jar that you can link into your apps, or it actually gets linked into the services.jar as well. There's all the clients, the ADLs, all that good stuff. Some helpers, and then the tests, right? We actually have really good test coverage in it too, so hopefully things will break less. But the custom system services, this is like the guts of like what makes this work. We have a config.xml, and there's some stuff in there that looks like this. We basically have the classes enumerated, like our status bar extensions, profile manager, partner interface that we use for like some of the stuff we're doing with Microsoft. Our telephony extensions, our hardware extensions, app suggestions, performance manager, and recently we just pushed like our whole themes feature over into the SDK as well, because it was like just sprawling across the whole framework and got unwieldy. So we moved that as well. But yeah, whenever a system server starts up, it reads this file and fires each of these up in turn. And you're kind of off to the races. If you want to add stuff, you can add stuff here, even with like just an XML overlay, or you can edit it directly, whatever you want to do. Like I mentioned, we added the settings provider, so we moved all the settings from the guts over into this new settings provider. It's mostly a copy of the main settings provider in a different namespace, and it's more, it's just a standalone thing. Anything that we previously had in like system.secure, system.settings, it's all moved to this, or settings.system, sorry. So yeah, just CyanogenMod provider CM settings versus Android provider settings. And again, it's automatic migration, and we moved everything to it. So every single custom setting that you find in CM is now in CM settings. The SDK library, again, it's like the ADLs and the manager classes, which are like we do a singleton pattern for all of them. Instead of like in Android normally we do like context that get system service, and then the service name. In our case, we just did some singletons. You pass up context, and hand you back the manager class forward with like a live instance of the service underneath that connects to the system server. There's a bunch of utilities and helper classes and other like random things that we use. A whole bunch of algorithms. I just shoved a whole bunch of like color math related stuff in there not too long ago. And, so there's kind of a nice lots of stuff you can use in your apps. We also did some neat versioning as well. So if you know how Binder works, there's some headers that are sent with like every request. What we did is, we passed like the class for the interface, and we also passed the API version. So, then you can make some determinations whether or not you have all the features, or if the services are changing, if you're running on a different version, or whatnot. So, again, it's about like degrading gracefully depending on what you're running on. So we try to pay a lot of attention to. We know not everybody uses CM, but we want to build out these features and once we start seeing like even more adoption, and hopefully people starting using this in their apps. So we're kind of thinking about that early. The artifacts are all in Maven Central. The only limitation that we really have is that you can't use the SDK from framework.jar, which is kind of to be expected because you have a dependency cycle there. But you can't use it from services. You can use it from all the apps. You can use it from everywhere else. We have some other trickery that we do, like to kind of eliminate the impact on framework.jar. But for all practical purposes, getting the settings out there was a big step. Getting the services out of there was a big step. And there's still more to do, but we made some good progress, and hopefully we'll be able to go faster. It's all documented too. That's the long link, but if you go to our main wiki, it's up there as well. Basically, what we've learned is it's getting harder and harder to maintain CM with these long Android release cycles, because not only does Google do a lot, we do a lot as well, right? So, and then there tends to be, a lot of toe stepping when it comes time to do that merge. So, we want to get out of the way of Google, and we want to start to exist more alongside rather than inside of Android. And that's not possible in every case, but in a lot of cases it is. And we're finding some creative ways to pull that off. So we're gonna keep ripping whatever we can like out and into CM SDK or other techniques. Apps are still a problem. We still have all this code in apps. So we're trying to make more like plugin based stuff. We talked about this mod platform that is coming on the commercial side, and that's kind of how we're addressing the app accessibility problem. So the goals are basically to ship faster and get more sleep, and we want to get our stuff out to more people faster. Especially on the commercial side, where we don't have things like nightly builds and all that. We have to, we have one chance to get it right, and then it goes out to devices, over the air. And if things break, then you're in for a world of hurt. So you got to make sure you get it right the first time. But that's it for me. So, you guys have any questions?
So do you contribute any of the code back into AOSP?
Question was, do we contribute back to AOSP? Sometimes. It depends on what it is. Like if they're bug fixes and that sort of thing, yes. In a lot of cases, it's also valuable to do just to get like some insight from like Google engineers too. Because sometimes you'll make a change like to view.java or something to fix some bug, and then Diane will like minus to it and like berate you because like you completely broke some other functionality or something. But it's good to get that kind of feedback. But we generally don't push features up because they don't take them anyway. But bug fixes, yeah, for sure. And we also push up a lot of fixes for the test suite as well. Because there's you always find stuff like for different devices and different environments too. So.
Do you think R8 will help with the whole different device trees for different kernels you have to create for each device rather than one unified?
Yeah, the question was does device tree help make things easier? Yes and no. Yes, because like the vendors like Qualcomm are taking it really seriously, and you can theoretically you should be able to. The problem is that what we see is that there's a lot of very low quality code in mobile, and there's OEMs and even like some of like our factory partners and stuff. They want to go as fast as possible and don't always do it right. So they don't always use all that functionality properly, and you'll still find weird stuff like interspersed like throughout like major kernel subsystems that shouldn't be there. But I think it's a big help. It's we use it extensively. Just you have to know how to use it. That's the whole trick, and I don't think that everybody has caught on to the right way to use it yet. So yeah, I think it'll get better over time though. So it's definitely better than it was. I think the biggest issue is still that there's so much code that isn't in Linux yet for production devices. Be it like sensors or even like pieces of Android that are like really new. It's just not in the mainline kernel. So that could take a while. Anything else?
Just a quick question for you.
Yeah.
You mentioned you partner with chipset manufacturers, factory partners, branding brands. How about mobile phone networks, the carriers? Do you have any partnerships there? Do you envision that as going forward in some markets?
So we have some stuff that I can't say too much about yet. I mean, carrier distribution is still, it's carrier distribution. On one hand, we're working on a project with one that shall remain nameless, that it's kind of like a challenge accepted type kind of thing, because like the test requirements are really high, and the level of quality you have to reach in a certain amount of time is really crazy. And I feel like if we can do that, we can pretty much do anything. So that's appealing on its own, but I think I think you're going to start seeing the carrier subsidies and whatnot, start to go away over time, and but you still need to do these certification processes if you want if you want it to be like an officially supported device on their network, whether or not they're subsidizing it or selling it in stores or not. And some of those are, it's still a certification process, right? It's still brutal. Yes, maybe.
We'll keep an eye.
Yeah, you'll see.
Any other questions in the room?
CyanogenMod always had really heavy community development work with it. Is there any sort of work from that translated over to Cyanogen OS?
Yeah, Cyanogen OS is CyanogenMod, right? It's literally built on top of it, right? And we do a lot of the work that is done for Cyanogen OS is all we do it all open source. We do it out in public and everything. So we're pushing tons of code there. But it's literally built on top of it, right? We have a couple of replacement apps. We pack some random stuff in. Obviously, we have all we build the full stack for our devices. So, we bring all that in as well. And there, maybe it looks slightly different. Different themes and whatnot. But yeah, at the end of the day, it's all the same. So we're very committed to supporting the open source project as well. So it kind of goes both ways. Anyone else? Cool. Thanks for having me.